Today's topic is lasers and its applications. First of all, the word laser is an acronym that stands for light amplification by stimulated emission of radiation. Laser is a device that amplifies or increases the intensity of light and produces high directional light. Lasers are essentially high directional, highly intense, highly monochromatic, and highly coherent optical sources. Laser emits light through a process called stimulated emission of radiation, which increases the intensity of light. This stimulated emission was postulated by Einstein in 1917. Einstein gave the theoretical basis for the development of laser in 1917 when he predicted the possibility of stimulated emission. In 1954, C.H. Towns and his co-workers put Einstein's prediction for practical realization. They developed a microwave amplifier based on stimulated emission of radiation. It was called as MASA, means microwave amplification by stimulated emission of radiation. In 1960, solid state ruby laser is developed by Myman on this principle. In 1958, C.H. Towns and A. Skaklow extended the principle of MASA to light. In 1960, T.H. Myman built the first laser device. And in 1961, gas-state helium neon laser is developed by Ali Javan and others in Bell Telephone Laboratory. Some lasers generate visible light, but others generate ultraviolet or infrared rays which are invisible. Principles of laser. There are three principles of laser. They are absorption, spontaneous emission, stimulated emission. We'll see one by one. First, absorption is also called as stimulated absorption of radiation. An atom in lower level absorbs a photon of frequency and moves to an upper level. Here is an atom. This atom from lower level moves to the upper level. Okay, this atom moves to the atom in lower level moves to upper level. Is called as stimulated absorption of radiation. Next, spontaneous emission. The transition of excited atom by itself to lower energy level is known as spontaneous emission of radiation. Means atom in an upper level can decay spontaneously to lower level. The atom firstly positioned in upper level, it spontaneously decayed to it was spontaneously, the atom in upper level spontaneously decayed to lower level. Spontaneously decayed to lower level is called spontaneous emission of radiation. Next, next one, stimulated emission of radiation means the atom after getting stimulated by incident photon transits to lower energy level by emitting photons is known as stimulated emission of radiation. You see, an incident photon causes an upper level atom. This incident photon causes an upper level. The atom which is in upper level, it causes to decay and emitting a stimulated photon. Okay, emitting a stimulated proton whose properties are identical to those of incident photon. The term stimulated, here the term stimulated underlines the fact that this kind of radiation only occurs if an incident photon is present. Okay, next, these are the three types of radiation. These are three types of lasers. These are three principles of laser. And next, kinds of lasers. There are so many kinds of lasers. Here some of the important lasers are listed here, like solid state laser, gas laser, liquid laser, dye laser, and semiconductor laser. In ruby laser is an example of solid state, and CO2 laser, helium neon laser is an example of gas. Europium chelate is an example of liquid laser. Cormarin dye laser is an example of dye laser. Here the word cormarin is new to us. It is a colorless crystalline solid with sweet odor resembling the scent of vanilla and a somewhat bitter taste. It is found in many plants too. And LNP is a semiconductor laser. LNP is nothing but lithium neodymium tetraphosphate laser. That is a type of semiconductor laser. Next, here we'll see one example of solid state laser, that is ruby laser. Here the construction of ruby laser. A ruby laser is a solid state laser that uses a synthetic ruby crystal as its gain medium. Let us see its construction and working. Construction of a ruby laser. In a ruby laser, a cylindrical ruby rod made up of aluminum oxide, which is doped with 0.05% weight of chromium oxide. Okay. And one end of rod is fully silvered and other one partially silvered, so it acts as optical resonator. Here one end of the rod is fully silvered and other end is partially silvered with aluminum. For this optical resonator is used to build up the light energy in the beam. They are essential for the operation of lasers. And the rod is surrounded by a glass tube, which in turn is surrounded by the helical flash lamp filled with xenon gas. Let us see the working of this ruby laser. When this flash lamp light will be flashed on ruby rod, chromium ions excited to higher energy states. After staying in higher energy state, after staying for up 10 power minus 8 seconds, ions get transferred into metastable state. The laser radiation of a wavelength of 6943 angstrom and laser emission is pulsed to 1. Next one here, gas laser. The example of gas laser is CO2 and helium neon laser. We can see about helium neon laser construction. This is some manual of helium neon laser. This helium neon laser is a type of gas laser whose gain medium consists of a mixture of 10:1 ratio of helium and neon at a total pressure of about 1 torr inside of a small electrical discharge. And this helium neon tube is enclosed between fully and partially reflective mirrors, which serves as optical cavity. As optical cavity, it describes an arrangement of mirror that produces a standing light wave resonator. And the two end windows are here. There are two end windows, right? These two end windows are set at Brewster's angle. I know you came the word across Brewster's angle in your +2, means it is an angle of incidence at which light with a particular polarization is perfectly through a transparent dielectric surface with no reflection. Okay, The angle of incidence that produces 90 degrees angle between reflected and refracted ray is called Brewster's angle. So the reflected radiations, so the reflected here, so the reflected radiations enter into the tube, become polarized. Next, let us see the working of this helium neon laser. Helium atoms, after transferring their energies to neon atoms, are excited to 2s and 3s. After transferring the energies of helium to neon, it was excited to 2s to 3s. Okay. The population in these levels is more than those in lower levels 2p and 3p. This emission of radiation having 6328 angstrom is here is in red in color, and it gives continuous emission of radiation from 3s to here 2p. Okay. Next, here are some, let us see some applications of lasers. Lasers are all used in different fields. First, lasers are used in communications. In optical fiber, communication laser bandwidth is very high compared to the radio and microwave communications. As lasers has a large bandwidth, more amount of data can be sent. So lasers will used in this communication. Next, lasers in industry. Lasers in industry can be used to blast holes in diamonds and hard steels. Laser systems in 50 to 300 watts range are used in primarily for pumping, plastic welding and soldering applications. Higher power applications such as hardening, cladding and deep penetrating welding require multiple kilowatts of optical power and are used in broad range of industrial processes. Lasers rangefinder is used to measure distance to making maps by surveyors. And lasers used in medical treatment. Lasers used in eye treatment. Laser eye surgery is a medical procedure that involves the use of laser to reshape the surface of eye. This is done to improve or correct short-sightedness or long-sightedness. The laser is very useful in removing extraneous blood vessels that can form on the retina. Lasers in military. Military use of lasers is a laser target designator. This is a low power laser pointer used to indicate a target for a precision guided munition, typically launched from an aircraft. It can serve as a war weapon. The lasers are being employed to destroy enemy aircrafts and missiles. And here are some advantages of lasers. Lasers are used to cut glasses and drill holes in ceramics, and it is used as for hardening, cladding, welding, like that. And lasers are used for bloodless surgeries too, in destroying kidney stones and gallstones, and these are used in eye treatment too. It is used to study the internal structure of microorganisms and cells. And these are also used to estimate the size of dust particles in air or anything. And here are some of the disadvantages. Lasers are known to be dangerous to atmosphere and health. And these laser printers, we have seen, I think you came across these laser printers. These laser printers are very costly when compared to other types of printers like tattoos or something. While running this laser machine, small amount of ozone are generated, which can damage ozone layer too, and it causes some, like it is dangerous to that atmosphere and otherwise health too. Some laser particles are also known to emit particles that may cause respiratory diseases. And finally, I conclude that the laser plays a crucial role in the modern world. Laser plays a pivotal role in the present technical world. Thank you for your patient listening. Have a nice day.